Okay, 1.2. Today, we want to go a little bit further into logarithms, and we've got three properties of logarithms. We're going to take certain logarithm expressions and expand them. Okay, there are three rules here that we need to know. Okay. Now, I'm not interested in asking you this and you giving it back to me, memorizing. That's not what I'm after. I'm just really interested in you knowing these properties and how to apply them. Okay. Now, the whole thing about logarithms is logarithms are the inverse of what? Exponents, okay? So a log equation, where's your exponent? Your exponent is always where? In a logarithm equation.
On the other side.
On the other side of the equal sign. So a logarithm really solves for the exponent, okay? When you multiply two numbers with exponents, what do you do to the exponents? You multiply two numbers with exponent. What do you do with exponents? Like a to the 7th times a to the 12th. What do you do with those exponents? You add them, okay? So what you're going to see here is that I've got the logarithm of two things multiplied. The log base b of m times n. That's the log of m plus the log of n. You're basically adding the exponents is all this really means, okay? So this first property is the product property. The log of two things multiplied is the log of the first expression plus the log of the second expression. So an example of that would be if I gave you the log base 4 of 2x, that's going to be the log base 4 of 2 plus the log base 4 of x, okay? So I can split that up into two logarithms. So the log base 4 of 2 times x is the log base 4 of 2 plus the log base 4 of x. Similarly, we have a quotient property. The log base b of m over m, that's the log base b of m minus the log base b of n. So in this case, if I had the log base 2 of 3 over x, that's going to be the log base 2 of 3 minus the log base 2 of x. Product and quotient. Are you okay, Carter? Oh, yeah. You think you could finish scratching your leg and put it down? So for anybody in period B and 7, that was Carter Welch scratching his leg. We're going to move. C Welch 125 on Instagram. 45, sorry. Okay. Okay. I had to check myself to not go down that rat hole. So, power property. Okay. Anybody needs to scratch their leg, go ahead and do it now. Okay. Anybody has a scratch, let's go ahead and take care of that now so we can keep moving on. Okay. The power property. The log base b of m to the nth power is n times the log base b of m. Okay. You basically bring the exponent out front. Now, how do we get that one? So for example, what if you had the log base b of x squared? That's the same as the log base b of x times x, right? So we're going to agree with that. According to our product property, this is the log base b of x plus the log base b of x. How many log base b of x's do you see there? That's 2 times the log base b of x. So all you do here is bring that exponent out front, and that's it, okay? So that's the power rule. Now, anytime you see an exponent here, you can bring the exponent out front, okay? Now, these are the three rules. They're going to be mixed in together, and you just have to know how to apply them, okay? So let's do a couple of examples. Use the product property to expand these, okay? So I've got the log base 6 of x times y. According to the product property, this is the log base 6 of what? We just covered the product property.
X plus log base property
plus the log base 6 of y, okay? The log base 6 of xy is the log base 6 of x plus the log base 6 of y. What about this? What does ln mean? It means what kind of log? Natural log, log base e, okay? So this is the natural log of 4, what?
X.
I need more. What's the product part? We covered it. Product plus the natural log of x, okay? That's all that is, okay? There's a typo here. We will continue using the product property for these ones below. And then I'll give you another example of a quotient. The log of 9x. What's the base of that? What's the base of that logarithm? Right, but what base is the logarithm? 10. Anytime you don't see it, it's 10. But you've got it right, Jake. This is the log of 9 plus the log of x. That's our product rule. What's the next one? The next one is what? Log base 7 of what? 4? Yeah, plus log base 7 of z. Okay? Now, let's do a couple, since I didn't have quotient, let's just do a couple of examples of a quotient. What about the log base 6 of 5 over x? Okay. Using the quotient rule, this is what?
Log base 6, 5.
Yeah, log base 6 of 5 minus log base 6 of x. Okay? So the product rule is the log of two things multiplied is it's the individual sum of those logarithms. The quotient is going to be the log of the numerator minus the log of the denominator. So let's do another example of that. Let's do, for example, the log base 4 of x over y. Okay? What is that going to be? Yeah, log base 4 of x minus. Yeah. There we go. Okay. Okay, you're tied, Jack. Come on.
Give mouse. No, I just give mouse.
Put your tie. Carter. Carter, you've already got 1 hour. You should be kind of. What about notes? Have you considered taking notes during class, Carter? Pardon me?
When my book comes in, I'm just going to rewrite all of it.
Okay. Okay, guys, let's get back to the math. Power property. Log base 5 of 4 to the x. According to the power property, what can I do with this exponent here? I can do what? Put it in the front. So this is going to be x times the log base 5 of what? Of 4. So with the power rule, whatever that exponent, the log of something to a power, you bring the exponent out front. So in this one, this is going to be equal to what? What's the exponent there? 4. So I bring it to the front. What am I left with? Natural log of x. Okay. So according to the power property, the log of something to a power, I can bring that power, that exponent, out front. Okay, pretty straightforward. So again, I've got 3 rules that I'm using here. I've got product, I have quotient, and I have power. Okay. So the log base b of xy is the log base b of x plus log base b of y. The log base b of x over y is the log base b of x minus log base b of y, and the log base b of x to the n is n log base b of x. Those are our three rules that we're dealing with: product, quotient, and power. Now, where it gets harder is when you've got problems that have all three. That's what we're after here. So, but I'm confident you guys can handle it. Okay. So look at this one. The log of the cube root of x. Do you have a rule over there that says how to deal with the cube root?
Not that I maybe, probably. No. The answer is no.
There's not. Okay, but does it look like a quotient?
It looks like a power.
Yeah, that's it.
Let's go.
So
That's Jack,
the
by
cube
way.
the cube root the cube root of x is x to what power? Yeah, 1/3. So the cube root of x is x to the 1/3. So I can write this as this is the log of x to the 1/3. Does that look like a product, a quotient, or a power? Looks like the power rule over there. So how can I write this? How can I expand the logarithm? So I can bring the 1/3 out front. So this is 1/3 of what? A quotient is when you're dividing something. There's no dividing going on. Well, we've got three rules here that we covered: the product, the quotient, and the power. So when I look at log of x to the 1/3, I don't see two things multiplied. I don't see two things divided. I see something to a power. So that tells me I'm using the power rule. Okay. So 1/3 log of x is what this is. Now the next one. Do I see products, quotients, or powers? What do you see there? Log 4 of x to the 4th of... I see a quotient. What else do I see?
Power.
I see a power. I got two things involved here, so I'm going to have to use both of those rules to solve this. Okay? So let's take care of the quotient first. This is going to be the log base 4 of x to the 4th, and then what? According to the quotient rule, it's the log of what? The numerator, and then what? Minus the log of the denominator. Okay? Does everyone agree? That's the quotient rule. The log of x to the 4th divided by 7 is the same as the log of x to the 4th minus the log of 7. Now, you look at your answer on the right. Do you see quotients, products, or powers? What do you see over here? There's a power. So how do I deal with it? How do I write log base 4 of x to the 4th? What do I do with that exponent? Yeah, this is 4 times log base 4 of x minus log base 4 of 7. Okay? So here I had cube root, but I had to recognize that was to the 1/3 power, so I used the power rule. Here I had a quotient and a power. I had to use two properties of logarithms in order to expand that. Okay? Let's look at the next one. Log base 8 of x to the 7th times y to the negative 4th. Do I see products, powers, quotients? What do I see there? I see x to the 7th times y to the negative 4th. So I see something to a power. I see things multiplied. Okay? In order to use the power rule, I can't bring that exponent out front unless it's the log of something to an exponent. So I can't bring both the exponents out front. I can't just take one of them because this 7th only deals with the x. That negative 4th only deals with the y. First thing I'm going to do is treat it as a product. So this is the log base 8 of x to the 7th, and then what? Plus log base 8 of y to the negative 4th. Okay? Now I have the log of something to a power. How do I simplify this first one? Yeah, that's 7 times the log base 8 of x. And then what? Yeah, minus 4 times the log base 8 of y. So again, you don't have to write down these rules. I'm not going to test you. You just have to know how to apply them. There are only 3. The log of 2 things multiplied is the same as the sum of their logarithms. The log of 2 things divided is the log of the numerator minus the log of the denominator. The log of something to a power, bring that exponent out front, times the log of that base. Okay? Let's look at the next one. What do you see? Products, powers, or quotients? I see a quotient. I see powers. I also see what? I see all of it. I've got 3 times x squared, so that's a product, a power, and I've got a quotient there. So I'm going to have to use every rule that I have to simplify this one. So let's start with our quotient rule. So this is going to be the natural log of 3x squared, what? Minus what? Yeah, the natural log of 2y. Okay, so I've used the quotient rule. Now, if you look at what I've written here, do I see products, powers, or quotients? What do I see now? I don't see any quotients, okay? I do see products and I see powers, okay? So now I'm going to have to simplify this. Let's look at this. This is the natural log of 3 plus what? Natural log of x squared, because this was 3 times x squared. It was a product, okay? Minus, I've got another product here, the natural log of 2y. How can I simplify natural log of 2y? That's a product. What do I do? It's the natural log of 2, and then what? Plus natural log of y. Now, this is simplified, that's simplified, that's simplified, but this is a what? Quotient, product, or a power? Power. So that can be simplified. So my final answer is going to be natural log of 3 plus what? What do I do with the power? Yeah, 2 natural log of x, okay, minus natural log of 2 minus natural log of y. That's about as hard as it gets in this section. So you can see what I had to do. I had to use the quotient rule to write this as the natural log of 3x squared minus natural log of 2y. And then I recognize 3 times x squared, that's a product. So that's natural log of 3 plus natural log of x squared. Natural log of 2y, that's a product, natural log of 2 plus natural log of y, but I'm subtracting it. And then I've got, okay, this is a power, so that's 2 times the natural log of x. So all 3 rules had to be used to get this one. Questions, Eric? I'm not sure. Or Lance, I'm sorry, Lance. All the stories about Eric, I mean, just, he's on vacation, he moved, he's got a girlfriend, and he died. Okay. Fell off a cruise ship. Okay. Okay, back to Lance. Are you doing okay? I can't tell. You okay? Okay. What about Wolfgang? Is he okay? He's looking back there at you too. You're horrible? Okay, what is it? No, come on. Is there something I can help? I'm just trying to get, is this going over? Okay. Okay. Okay, a couple more here. Log base 4 of the square root of 4x. She was. Okay. Okay, guys. Log base 4 of the square root of 4x. Do we have a rule over there for square roots? they're going to hate y'all, I think. Yeah. The log base 4
No,
of
stop, Matt. No master.
log base 4 is square root of 4. Do I have a rule that deals with square roots? No. Okay. So my only hope is, can I write the square root as something else? Yeah. The square root of 4x, that's the same as 4x to what power? Not today. Not today. No. On Wednesdays, what is the square root of 4x? It's 4x to what power? Somebody. Yes, this is a Wednesday.
-2.
Come on, guys.
-4.
No, I will wait for this one.
4x. Square root of 4x.
No, it's x to what power?
4.
No. Well, you knew a minute ago what the cube root was. It was x to what? The cube root of x was x to what power?
Cube root of x. What? Oh, 1/4. Yes.
Okay, a minute ago.
One half.
There we go.
Let's go.
If the cube root of x was x to the 1/3, the square root of 4x is 4x to the 1/2 power. Okay. Okay, guys, you got to know this. We started this back in August. Okay. The square root is the same as something to the 1/2 power. Okay. So this can be written as the log base 4 of 4x to the 1/2. Okay. Do I see products, powers, or quotients there?
Powers.
I see powers and I see products. So I'm going to be using two of those rules there. Since everything is raised to the 1/2 power, I can bring this 1/2 out front. 1/2 the log base 4 of 4x. Now what do I see the log of a what? Log of a product, quotient, or a power? Log of a product. So this is 1/2 log base 4 of 4 plus log base 4 of x. Okay, what's very important here, guys, it's 1/2 times all of this. It's 1/2 times log base 4 of 4 plus log base 4 of x. Okay? Yeah, you could write that. You could write it like 1/2 log 4 of 4 plus 1/2 log 4 of x. That would be correct as well. The power rule is what got us from here to here. Okay, I brought the 1/2 out front. And then I said, oh, the log base 4 of 4x, that's the product rule. Log base 4 of 4 plus the log base 4 of x. So you had to use two rules to get this one completely simplified. Okay? Let's look at the next one. Ln. Ln means what? What kind of log is that? Natural log. Log base. Natural log is log base what? E. Okay? So is this, do you see I'm taking the log of what? Powers, products, or quotients? What am I taking the log of? It's a quotient and powers, okay? So first thing I'm going to deal with is the quotient. So this is the natural log of e to the 6 minus what? 7, okay? Natural log of e to the 6 minus natural log of 7. And what can I do with this one now? Yeah, this is 6 times the natural log of e minus the natural log of 7. Now, I would probably take this as a correct answer, no points taken off. But I probably would. I think I am. It's right. But what I'm saying, I would take that as an answer. But there, you can go a little bit further on this one, okay? So for example, ln of e, that's the log base what? Log base No. Natural log is log base. Yeah, so the log base e of e to the first power. That's what this means. So, what do you know about the log and the exponent? Those kind of functions are what to each other? They're inverses. So what would happen if I take the number 1, I raise it e to that power, and then I take the natural log base e? What happens when I do a function and it's inverse? What do I do? Think about this. You square a number and then you take the square root. What do you end up with? The number you started with, okay? So, if you start with the number 1 and you take e to the 1, that does something to the number 1. But the log base e is an inverse function. What does that do to what you just did? It undoes it, okay? What's the answer to this? What is the log base e of e to the 1? No. Yesterday I said the log base b of b to whatever the heck, for lack of a stronger language, is what? It's just whatever that is. So the log base b of b to anything is the anything. This is just 1. Okay? These are inverse functions of each other. So if you were to take e to the 1 and then take the log base e of that, you get 1. You get what you started with. So this is just 6 minus natural log of 7. Either of these would be the good answers. Okay? So like I said, I'm not requiring you to go all the way there, but that one could go a little bit further. Okay, any questions over this? So guys, it's very important you keep up with this on a daily basis, Carter, because, like I said, the test is coming up, I think it's a week from yesterday, or 2 weeks from yesterday. So yeah, keep up with this. This is stuff you haven't seen before. I mean, am I right? You haven't seen logarithms before. Okay. It's not that it's heavy computational, but it's different. And it's the kind of topic you're either getting it or you're not. It's hard to like halfway get logarithms. So the light either has to all the way go on, or it's not going on. So anyway, spend time with that. So I'll pause.